So today we'll start from that diagram which we discussed last day, and we'll move on to the CPM method or critical path analysis method of analyzing that network. A critical path is the longest path through the entire network. The length of critical path is also the shortest time allowable for the completion of the project. All activities on the critical path should be started as soon as possible to complete the project in shortest time. All activities along that critical paths are known as critical activities, and any delay in completing the critical activity will increase the project duration. And if we want to complete the project ahead of the schedule, the time required for at least one of the critical activity must be reduced. The activity which doesn't lie on the critical paths are called as non-critical activities. These activities have some slack time, or also called as float. The slack or float is the amount of time by which the start of an activity may be delayed without affecting the overall completion of the project. Obviously, a critical activity doesn't have any slack or float. And to reduce the overall project time, it would require more resources to reduce the time taken by critical activities to complete. Now, scheduling, how to do the analysis. So we define two types of times: earliest time or earliest start time and latest start time. So earliest expected time at which the activities originating from an event can be started is denoted by earliest time, or E, in this particular lecture. Latest time, L, the latest allowable time at which the activity terminating the events can be completed. To compute the earliest time, we go through a forward pass, and to compute the latest time, we use a backward pass. So first we'll use an example, and then we'll move on to discuss all these components. So like here we have an example. So certain activities are given here, like activity A, which requires 4 units of time. This is basically given in days, so 4 days, which requires 4 days, and this is denoted in the diagram by activity 1, 2. Similarly, activity B is denoted by activity 1, 3, and it requires 1 time. So if we just draw a network diagram for this, which is shown here. So now you can see activity 1, 2 is denoted by, or has a name A, and it requires 4 units of time or 4 days. Activity C requires 1 day, B requires 1 day, D requires 1 day, E requires 6 days, and so on. Now, to compute the earliest start time, or E, so E at this start event is obviously 0, because this is when the project will start, and this activity will finish at 0 plus 4. So next activity, that is C, can start at 4. So this 4 is basically 0 plus 4, and this 4 is basically this one. Similarly, activity B starts at 0, so obviously it will finish at 1 because it requires just 1 day to compute. So 0 plus 1. So this is how this is computed. Now for activity where this activity or event, when this event 4 will finish and event F or activity F can start. So along this path, now we can say that event F can only start when both these activities C and D have finished their processing. So when C and D will finish, so C will require 5 days to finish. C will finish at 5th day because it starts at 4th day, and so obviously it will end at 5th day. Whereas D starts at 2nd day, so after 1st, and it will finish at the end of the 2nd day. So it will finish at 2. So it will finish at 2, and it will finish at 5. So when can this activity F can start? So we say that the max of these 2 times, so this 5 and 2. So this will give us this time. So that's why we can see that this is 5. In this case, at event 5, say it starts at 1, requires 6 days to compute, so it will be completed at 7th day. So at 7th day onward, both these activities H and G can start. Now G can finish at 11 because it starts at 7, it requires 4 days, so it can end at 11. Whereas H starts at 7, requires 8 days, so it can end at 15 days. And now to start event activity K, so activity K can be started only after activity J and I both have finished their processing. So how long they will take? So again here we require max of these two events. So basically max of 15 and 11. So max of 15 comma 11. So obviously this is 15. In this case it starts at 5th, requires 5 days, so it will end at 5. And now when the final activity or the final project will be completed, obviously along this path it will require 15 plus, sorry, this should be 17, this should not be 15, this should be 17 because 15 plus 2, so this should be 17, I'm sorry here, this should be 17, so there is a mistake. So this will be 17, so 11 plus 1 12, so this will be 12, so max of 17 and 12, so this will be 17, so 17 plus 5 22 and 10 plus 7 17, so maximum of that, so 22. So if we say, then all the activity E can be computed like this. So E1 is 0, E2 is 4, E3 is 1, E4 is maximum of these two, so 5 days, E5 is 7, 6, 11, 15, 17, 10 and 22. Now in case of L, so this is the latest time, so we go in a backward direction. So we start from the end activity or the last activity and we move backward to the start activity. So it finishes at 12. So if it finishes at 12, when can this activity be started? So this activity has to start at 17 because it finishes at 22. So minus 5 because it requires 5 days. So it has to be started at 17. Otherwise this whole project cannot be finished on 22nd. This activity, it finishes on 22nd, it requires 7 days. So this activity could have been started on 15 also. Similarly, so this is 17, so it requires 1 day, so this can be on 16, this has to start on 16. Let us start on 16, this has to, this is 17, this is 2, so this will be on 15. Now if we move backward, so this 8, so 15, so 7, and this is 16, 4. So now here, so along this path, it requires, it will be, so here the latest time here will be, so let me just choose another color, how to choose that, same color, so if I take blue, so it will be mean of minimum of, in this case along this path it is 7 and along this path it is 16 minus 4, so 12. So this will give us 7. So this activity has to start on 7, this activity, because the latest, otherwise this activity cannot be finished. Similarly, this is 7, so this will require 6 days, so this has to start at 1. And moving backward, so this was 15, so minus 5, so this can be 10. Now 10 and again, and here, so it will be 7 minus 6, so 1 and minimum of 1 and 10 minus 1, 9. So this will be minimum of 1 and 9, so this will give 1. Along this way it is 10, 1, so 9. And here again it will be minimum of 1 minus 1, 0, and 9 minus 4, 5. So it will be 0. So the calculation is shown here. Sorry, so this one. So L10 is 22, L9 will be 22 minus 7, 15, L8 is 17, L7 is 15, 6 is 16. Now 5, because at 5 you can see 5 at 5, 2 nodes were going out, so it will be minimum of those two. So minimum of is 6 minus T5, 6, and this one, so 16 minus 4 and 15 minus 8, so 12 and 7, so 7 days. E4, L4 is 10. Again on L3 we have two different edges going out, are two activities starting from this 3. So we'll take minimum of those two, so that will give 1 day. At L2 it will be 9, L1 it will be 0. So that's how we calculate. Now let's have a formal definition of all these things. So this is what is shown here. So in forward pass computation, so begin from the start event and move toward the end event. E0 for the first event, E equals to 0. Go to the next event. If there is an incoming activity for event 2, add E to the previous event and activity time. If there are more than one incoming activities, calculate E for all incoming activities and take the maximum value and repeat the process. Whereas for latest time L, move from back end and move towards the start event. Latest time L for last event is the earliest event at the last activity. So last event, that is L last event equals to E last event. And if there is an incoming activity, subtract the value of L of previous event from the activity duration. And if there are more than one incoming activity, take the minimum L value and repeat this step. And that's what we did. So that's what we did in this figure, as well as the calculations are shown here. Now, once these calculations are done, we can now create a float. So as we told, a float or the slack time of an activity is the amount of time available by which it is possible to delay the completion time without extending the overall project completion time. So if we define certain notations like Tij is the duration of activity Ij, Ei is the earliest expected time for the activity I, Li is the last allowable time for activity I, ESI earliest start time for activity Ei, and EF earliest finish time of activity. Similarly, LS represents the latest start time and LF latest finish time of activity. Then total float for the system can be computed as total float equals to last start activity minus earliest start activity, or Lj minus Li. So if we see in this figure, we can find out the different, say, which is shown here. So if we note down everything, like for activity A, the normal time is A, starts at 0, finishes at 4. And latest start, if you see here, latest start was on it was on 9th day also it could have been started. So so latest finish was 9, and so latest start, so this activity could have finished on 9th day also without any problem, because even if it finishes on 9th day, this activity can start on 10th day. That's the formula. So latest finish time for this is 9, and latest start time obviously can be 5, because that's how we can do it. So latest start is 5, finish is 9. So similarly, if we move on, then subtraction of these two, so this minus this or this minus this will give you the total float. So any one of these figure, like in this case this is 0, in this case either 10 minus 5 or 9 minus 4, either 10 minus 2 or 9 minus 1, so it will give the same value. Now you can see that there are some activities where this float is 0, and all these activities are called as the critical activity. So if we move on here, so this is the float we discussed. And if an activity is a critical activity, both the conditions are satisfied. That is, L minus A equals to 0 and Lj minus Tij minus Ci equals to 0. So in this diagram, if we see, we can say that this activity, so you can see that activity 1-3, then next activity is 3-5, so activity 3-5, the next activity is 5-7, so 5-7, next activity is 7-8, so 7-8, and next activity is 8-10. So these activities are the critical activities as their floats are 0. So you cannot have any delay on this project, on this particular path. Whereas you can have certain delay on other paths and still you can finish the project on the deadline. And those delays are basically the slacks which are shown here. So for this particular class, we'll stop here.